Okay, good morning, everyone. We'll get started. So I want to show you something really quickly. So I have decided to extend all the quizzes until the end of the semester. Okay. Let me show you. So you should have until May 11th, right, to finish chapter 6, 7, 8, and then 10 homework assignments, and then also the quiz, right? And then homework assignment, you don't need extension. You can work on it after due date. So I didn't extend those, but there's no penalty for late submission. Okay. Now you can easily find it, right? When you log into the homework system, you'll be able to see all those quizzes, being extended. Okay, May 11th, right? Okay. And you're taking the final exam on May 12th. Okay, that will be the plan. All right, any question on the final and any other concern? Okay. All right, so we're going to continue on chapter 6. Okay. And chapter 6 is about normal distribution. All right, so let me share the screen first. All right, so there's another distribution called uniform distribution, chapter 6. Let me just briefly talk about uniform distribution. So we're still on chapter 6. Normal distribution. Last time I actually talked about standard normal distribution. And let's take a look at the uniform distribution really quickly. So basically, uniform distribution has a rectangle distribution, right? The shape of the distribution is rectangle. Basically, there are two important parameters here. First one is starting point and end point. And basically, for uniform distribution, within this interval, right, from A to B. So let's say the discrete random variable belong to this interval from A to B. Then the probability will stay the same. So this is the height here. Height here represents probability. And the important thing is the probability to remain the same. That's why we have a rectangular shape here, right? Due to the fact that the height remains the same, meaning probability remains the same. So P of X remains the same. And a uniform distribution is a special type of probability distribution. That means that the total probability under the rectangle for this rectangle will be 1. So this total area of the rectangle here equal to 1. Meaning total probability equal to 1, right? That's basically where this area of this rectangle equal to 1. So that being said, if the total area equal to 1, then the height, we can express the height of probability using A and B, right? So the base here should be B minus A. If you look at this, the base got to be B minus A. And then we're assuming this height, right, is the probability of X. Okay. So probability of X times B minus A, that equal to total probability equal to 1. Then we can express the probability in terms of A and B by just dividing both sides of the equation by B minus A. Okay, then you cancel the common term on the left. So probability of X equal to 1 over B minus A. Okay, so basically here the probability is always equal to 1 over B minus A. So the height and the probability is closely related to the base. Okay, for this particular case. And there's some homework examples, right, about this uniform distribution. We can take a look at one of them as an example. Okay, let me just share the screen with you. All right, let's go to chapter 6 homework. One of them is about the uniform distribution. I think it's something like question 5 or 6, but let me double check. Okay, no, not this. Okay. 7 maybe. Okay, no. Maybe question 3. Yeah. Okay, this is one of the question, right? So basically, a statistics professor plans class so carefully, the length of the class uniformly distributed. So this is indication it's a uniform distribution based on this keyword, uniformly distributed. Between 48 and 58 minutes, find the probability that a given class period runs between 50.7, 50.75 minutes, and 51 minutes. Okay, let's take a look at how we apply this to solve the problem. Right. Let's apply the uniform distribution here to solve the problem. So first of all, you want to present it in a graphical form, right? So you're just going to draw this. You could draw a rectangle if you want to, right? So here, let's draw a rectangle right here. And then the base here will be between 48. So the starting point is 48 minutes, ending point is 58 minutes. And then any time in between will be possible, meaning the professor could end the class any time in between, right? So they all have the same probability here. And now, first of all, we want to find out the height or the probability for him to end the class, for him or her to end the class. So now we're using that. So probability of X should be equal to total area 1 over the base. The base will be 58 minus 48. That turned out to be 10. So it's 1 over 10. So the height here is actually 1 over 10. If you turn it decimal, it will be 0.1. So this means probability for any given moment to end the class will be 1 over 10, which is 0.1. Okay, so we have that. Okay, so basically we have idea, right? So the 10% of chance that this professor will end the class between 48 minutes and then 58 minutes, and then any given moment in between those two time frame will be possible. And now the question is, find out the probability that given class period runs between 50.7, this is 50.7, and also 51 minutes, right? So now basically you are just trying to figure out what's the area here. Area represents probability, okay? Area is the same as probability. So we just need to figure out the area here. And we know, remember that the height is 0.1, right? So for any rectangle, you just, in order to find out the area, you just use height times base. So here the total probability for class time runs between 50.7 and then 51 minutes should be a height 0.1 times the base will be 51 minus 50.75. And if you simplify a little bit, it will be 0.1 times 0.25, right? And it will become 0.025. That means with a 2.5% chance, this class will run between 50.75 minutes and then 51 minutes, right? So that's how we apply the uniform distribution to solve the problem. And now let's move on to and we talk about the standard normal distribution from the last time. So let me just quickly remind you what we're being talked about. So for standard normal distribution, two key aspects. First aspect is the mean equal to 0. And the second aspect is standard deviation equal to 1, right? So if there's a normal distribution, it satisfies mean equal to 0, standard deviation equal to 1, we call this standard normal distribution. And the thing about this is, if you look at a z-score, when mu equals 0 and the standard deviation equal to 1, x minus mu over sigma, if you throw in the numbers into the formula, right, mean equals 0, so you get x minus 0 over sigma 1. So basically it's x over 1. So the good thing about the standard normal distribution is z-score is same thing as x value. So if the question tell you that, it's a standard normal distribution, then whatever x value they give you in the question, that will be the z-score. And then you can use z-score to look up the probability from the table A2, right? Pretty straightforward. And if you look at one of these questions here in your homework, it's about, you see, for this one, the graph depicts a standard normal distribution with a mean 0, standard deviation 1. So this is exactly the standard normal distribution. And they are given the z-score here. So you can just look up quickly in the table, find out the area to the left, and that's the end of it, right? And that's another question here. I think it's going backwards, something like this, right? If let's say you are given the area, right, under the bell curve. Okay, so the area is still a standard normal distribution. And the area to the left-hand side of this z-score is 0.9732. And they want you to find out corresponding z-score. So that's like going backwards, right? So let me just open the table really quickly. Let me show you how to do this. This one is, you also need to know how to do this because it's very useful. Given any probability, you'll be able to find out the corresponding z-score. From there, you'll be able to going backwards to the x value. Okay. All right, so open your formula sheet. Let's go to the table A2 in your formula sheet. If you go down a little bit, you should be able to find the table. Okay, so it's on the second page because the probability is bigger than 0.5, right? The first page, the probabilities go all the way up to 0.5, right? It's the lower half, so it's 50%, so it's 0.5. So anything above 50% or 0.5 will be on the second page of table A2. And here the given probability here is 0.9732. So that's a probability. So it's in the center. Probability is located in the center, right, of the table. So 0.9732. Let's see the closest match. Actually, we have an exact match here, and this turned out to be the corresponding z-score will be 1.93. So the z-score always have two decimal, 10th digit and 100th digit. So you need to combine those two, right? 1.9 plus 0.03 give us 1.93. So the corresponding z-score here should be 1.93. Okay. And that's what the question is asking you. So you need to know how to do both, right? Let's say, given z-score, find out the probability, and given the probability, find out the z-score. It's exactly the opposite process. Okay, and this is about the standard normal distribution. And now next, let's move on to standard normal distribution. Okay, so for normal distribution, basically, this is more general case. It's very widely used, right? You can find in any field, you can always, with a large data set, and the data set always follow the normal distribution, right? And basically, we using z-score formula to compute some, to do some calculation and find out the probability. And let me give you an example. Let's say the average, the mean IQ score for adults is, let's say, 100, and standard deviation is 12. And now let's find out the first one. Find the percentage of the adults who has IQ score which is below, let's say 85. Find the percentage. Find the percentage of adults with the IQ score below 85, let's say, right? So so this is one of the typical question, all right, about the and the second one, let's find out the final probability. Percentage is also the probability, final probability of adults with IQ score between let's say 90 and then 110, okay, something like that. And let's not use symmetrical number. Let me use 105 then. And let's do maybe 125. Let's do that. Okay. So this is second question. Third question is find the percentage of adults with IQ score above 115, something like that. Basically, we have three different scenarios here, right? And then assuming the distribution, if you look at the general, the population is definitely it's a normal distribution because we have the huge data set. That's always the case. So so normal distribution applied to the large data set, especially for this scale. Assuming normal distribution applies here. So basically, this question covers all three scenarios. Okay. First one is a below, right? So you probably want to draw a bell curve and try to visualize this. So draw this bell curve, and then the mean is 100. Okay. So this is the mean, right? It's given in the question. First thing say, and then standard deviation is 12, and we're assuming we want to find out percentage of adults with IQ score below 85. Okay. Okay. This is 85 here. So X equal to 85. So we try to figure out what percentage, right? What's the probability of a random select adults with IQ score which is below 85, and you want to basically find out area under this region right here. So we're looking for the area on the left, to the left-hand side of this IQ score 85. So first of all, we're using the z-score formula to find out the corresponding z-score, x minus mu over sigma, and both mean and standard deviation is given, right? Means 100, standard deviation is 12. Okay, both of them are given. So what we want to do is x is also given, right? X is 85 in this case. So we throw it into the formula and find out the z-score. So z-score is like the middleman. So middleman connecting the actual IQ score to the corresponding probability. So let's find out the z-score here. So it's going to be 85 minus 100 over 12. So this turned out to be negative 15 over 12. So it should be negative 1.225, is it? Yeah. Negative 15 over 12. Okay. And this is going to be, yeah, negative 1.25. So now basically we converting the IQ score to the z-score. So we turn into a standard normal distribution, right? Okay. So here you draw another bell curve. Okay. So now for this standard normal distribution here, standard normal curve, then the z-score in the middle is 0. Now our z-score here is negative 1.25, so z-score equal to negative 1.25, and now we're still looking for the area to the left. Okay. And we're using this z-score and then look it up on the table to find out the probability or the area to the left. So now we go back to the table A2. Okay, and then you look at the table A2, and we're using negative 1.25. Negative 1.25 should be on the first page of the table A2. 1.25, you go down a little bit, it should be 0.1056. 0.1056, right? That's corresponding probability with a z-score equal to 1.25. All right, so basically you find the answer because the table gives us the area to the left. Okay, that's exactly what we're looking for. So we got that 1056. So if you go back, the answer here should be probability for the IQ score x less than 85, right? IQ score less than 85. It's the same thing as saying probability for z-score less than negative 1.25. And the probability turned out to be 0.1056. Okay. And that's the whole procedure of finding the probability using the z-score formula, also the table A2, right? And I can also show you how to do that in Excel a little bit, right? Later when we talk about the Excel project in a bit. Okay. But yeah, that's how we solve the problem here. Okay, then let's look at the part 2. So the part 2 is about find the percentage of the dots with IQ score between 90 and 125. So this is in between, right? Second case is between. First one is below. Okay, and then also above, right? So we have 3 different scenarios to cover here. So between 90 and 125. So probably. So now again, you draw the bell curve. And the mu is 100. It's right in the middle. The mean split the entire bell curve into half and half. On the left half is 50%, on the right half is 50%. And we're talking about this x equal 90 and then 125. Yeah, 90 and 125. So 125 should be here. So basically we're looking for the area in between. So this is kind of the second case, right? In between. And first of all, here we need to do 2 things. We need to convert the higher z-score, higher IQ score into the z-score. So first case, when IQ score equal 125, let's see what is the corresponding z-score. So mean is 100, standard deviation is 12. So the z-score for the 125 should be x minus mu. over sigma. So it's 125 minus 100 by 12. It's 25 over 12. And then here we don't have exact answer, so we have to run it to 2 decimal place. So this turned out to be 2.08 approximately. Okay. Now we run into 2 decimal place. That's always the case for the z-score. It's also the convention because in the table A2, we only can use up to 2 decimal place. But in the Excel, we can use much more decimal places, meaning using the software or the Excel, you'll be able to get much more accurate answers. Okay, the table has limitation. Second one, let's find out for IQ score equal 90, mean equal 100, sigma equal 12. What is the z-score? Z-score equal to x minus mu over sigma. So it's 90 minus 100 over 12. So this is negative 10 over 12, right? Let's see what that is. Approximately negative 0.83. Again, I run into 2 decimal place. All right. Now, since we do the convergence, so this becomes this. Standard normal curve, right? So again, we draw the bell curve. Mean in the middle now, so standard normal curve, z-score equal to 0, right? And then for the higher z-score, it's 2.08. So the z-score for the IQ score of 125 is 2.08. And then z-score for the smaller IQ score, right, is negative 0.83. So it's right here. And again, we're looking for the area in between. Now think about this. In order to find out the area in between, we probably want to find out the area or probability for z-score equal to 2.08, because that will include this shady region plus this circle, right here, this region. And the area corresponds with z-score equal to negative 0.83, exactly circle region. If you subtract these 2 regions, and we end up with the shady region, that's what we are looking for, right? So first of all, we're using the bigger z-score. So if you want to write it as a professional form, will be x greater than 90. So meaning IQ score greater than 90, less than 125. And this is equivalent to z-score greater than negative 0.83 and less than 2.08. And now we're using z-score equal 2.08. Find out a bigger probability first. So go to the table A2, second page. Look for 2.08 first. 2.0 is here, and 8, it should be that, right? So we get this 2.9812, and that's a total probability, a total area accumulated to the left. So it's 0.9812. Using bigger area minus smaller area, the circle area there, and go back, look for negative 0.83 on the first page of the table A2, negative 0.83. It should be this, 0.2033. Okay. 0.2033, and let's see what the difference is. 0.2033. And the difference is the shady region we're looking for, right? It's the answer we're looking for. So 0.9812 minus 0.2033, and this turned out to be 0.779. And that's basically what that is. Okay. And that's area we're looking for, right? So it's about 77.79% of the adults have an IQ score between 90 and 125. So this is very useful in terms of providing the information for the general public. And if you think of a lot of like universities, especially those top tier universities, when they select the students, for the enrollment, they also consider the SAT score, right? And also other curriculums and then all those different things. But in terms of SAT score, you also follow the normal distribution, for the entire population. Matter of fact, for all populations, right? For all big populations, they all follow normal distribution. So you will see this bell-shaped curve apply to any topic you try to study, So it's very, very useful. Okay, and then PASI is about above 115. So now you're looking for the area to the right. Okay, so let's look at it quickly. So PASI, so draw the bell curve, right? Means 100 in the middle. Now the IQ score is 115. And it's above 115, meaning we want area to the right-hand side of the IQ score. And basically, remember from the table, we can find an area to the left. Okay, and then if you want area to the right, then you're going to use total area 1 minus area to the left. And that's how we get area to the right. So this is general principle. If you want to find out the area to the right-hand side, that's what we do. So first thing we do is converting the IQ score to z-score. So x equal to IQ score equal 115, means 100, standard deviation is 12. So let's find out the corresponding z-score. So x minus mu over sigma. So it's 115 minus 100 over 12. And this is 15 over 12. And it turned out to be 1.25. So now this IQ score becomes z-score of 1.25. Now we can create another bell curve with z-score. You use only, okay, so they do that. So z-score in the middle is 0. So now our corresponding z-score is 1.25. And we want an area to the right. Okay. Now basically go to the table A2, find out the area to the left, because the table A2 only provides us with area to the left. So 1.25, let's see the corresponding probability here, 1.25 should give us 0.8944, right? 8944. And that's area to the left. Remember, it only provides area to the left. And then if you want area to the right, we're going to use 0.8944. Double check one more time. Yeah, 8944, that's good. Now let's go back. So the area to the right-hand side here, so probability for IQ score greater than 115, the same thing as probability for z-score greater than 1.25, and that will be 1 minus 0.8944. And this turned out to be 0.1056. So that means in the general public, for the entire population, 10.56% of the adults have IQ score which is above 115. So you'll be able to interpret it, right, with this probability, computing. Okay. All right. Any question about the normal distribution? It's very useful, right? It's going to be useful for chapter 7, 8, for a lot of different, moving forward. If you're going to any other more advanced statistical course, you also need this. Yes, Kiara, you have a question?
Yeah, I was just, how did you say we could find the z-scores that aren't on the table?
The z-scores are not, oh, I see. So for example, if you have a z-score which is 5.62, right? Let's say
Yeah.
something like that. Very good question though. Or something like z-score which is equal to negative 3.99, something like that, right? You won't find it from the table. Yeah, but actually, you could find it. It just it's a little. You see, 3.50 or and up, they all have the same value, right? So they all 0.9999. So no matter it's 5.60 or 100.60, you're using the same probability because when you run into 4 decimal place, it's the same. And this table has limitation, right? Because if you're using Excel, you'll be able to run it to more decimal places. Then you'll be able to differentiate the probability. And let me maybe quickly show you this. Let's say, let me open Excel. Let me show you how do you find the probability in the Excel. Okay. I just open it. Give me 1 second. Let Excel show up. Okay. And also for negative ones, by just using the table, anything below negative 3.50 is the same value, right? So no matter whether it's negative 4.99 or negative 100.99, right? Same number. You use the same number. So that does give you some. If you're using the table, that's what it is. But again, the actual value may differentiate a little bit, right? Let me show you really quickly in the Excel how you handle this. And again, you do want to differentiate them, right? Because they are different. They're not the same. Unless you run into 4 decimal place, they are the same. Otherwise, they are different. So for example, let's say you want to find out the probability, right? So you do norm.s.dist, and this means standard normal distribution. And if you're given a z-score here, okay, let's say, for example, you want to find out what is 3.99, right? For z-score, which is 3.99. And second argument is cumulative, meaning are you accumulating everything to the left? Yes, should be yes, right? So we do yes. True, right? We type in the argument true. Okay. Means we accumulate everything to the left. Now you can see that. You see, if you run into so that's more accurate answer, right? Compared to what we have in the table. And also, if you using another one will be norm.s.dist. If let's say you have a 10.99, right? Which is huge z-score. And then again, argument is true. You see, it's almost 1, but not exactly 1, right? Again, we're gonna run it to, let me just format it and run it to, let's say 20 decimal place, maybe 200. You couldn't show 200, so maybe 50 decimal places. So yeah, so it's almost 1, right? So here that it does differ a little bit. Okay, and maybe let me be less dramatic and let's say 5.99. Then you'll be able to see that. You see, they do differ a little bit, but not too much, right? That's why the table is just a rough. It's not 100% accurate, but again, without using technology, the table is the most accurate source, right? If you're using any software or Excel, you'll be able to get much more accurate answers. I'm going to show you later, right, how to going back and forth about finding the probability given a z-score or find the probability given the actual x values. Okay, in a bit. But yeah, it's a very good question though, Kiara. Okay. Anybody else have a question about this? Okay. So for anything above 3.50, then we always use, it's always 0.9999, right, from the table. And if for anything below negative 3.50, it's always 0.0001. Okay. It's accurate answer, right, based on the table. But if you want more accurate answer, you have to use Excel or any software I mentioned in the beginning of the semester, like R, SPSS, SAS, all those different statistical analysis software will give you also accurate answers. Okay. And now let's look at one of the most important application of the normal distribution. Is called central limit theorem. So basically, central limit theorem is one of the most important application of the normal distribution. So basically, central limit theorem is comparing the sample mean, right? So basically, is compare the sample mean to the population mean, and then also find out relative standing of all the sample means. So central limit theorem does not focus on each individual data values, right? It doesn't focus on X, right? So for the regular normal distribution, you focus on X. X is the main subject. But for the central limit theorem, we focus on X bar, meaning you focus on sample mean. You have a sample, you pick a sample, and you try to compare the sample mean to the population mean and find out the relative standing. So this is the main aspect, of the central limit theorem. And based on a lot of studies and then a lot of experiment, people find out this: the mean of all the sample means is same thing as population mean. Second, this is first finding. Second finding is standard deviation of all the sample means is equal to standard deviation of the population over square root of sample size. Okay. And this term is mu of X bar is what we call the mean of all sample means. And mu is just basically population mean, right? Population average. Here, sigma with the lower script X is what we call the standard deviation of all the sample means. So sigma of X bar is basically saying standard deviation of all sample means. And sigma here is basically population mean. And then n is the sample size. So if you want to use a formula to representing the central limit theorem, you can just do this. So using this formula could be z-score equal to sample mean minus population mean, right? Compare the sample mean to the population mean, and then it's over standard deviation is sigma over square root n. Okay, so this is basically the formula for central limit theorem. You can also just use abbreviation CLT, right, to represent the central limit theorem. And now, if you want to apply this, let me just give you a very simple example, right? Like the one we did from the previous question. Let's say adult IQ, average IQ score, the mean IQ score for all adults in the US, let's say, is 100, stay the same for all adults in the US. is 100, and standard deviation is 12, remains the same. Standard deviation is 12. Okay, and assuming it's normal distribution, it has to be normal distribution. Assuming the distribution is normal distribution. Now let's find out percentage of adults with average IQ score, right? Let's find the percentage of adults, the percentage of people or adults with average IQ score of 108 in a sample of 20, right? So basically you have a sample of 20 people, 20 adults, and you want to find out the average IQ score of 108, right? IQ with average IQ score of that will be below 108. Okay, so below 108 in a sample of 20. Okay, so this being said, you see, now we have a sample of 20 adults, right? And we want to make sure that the average IQ score for those 20 adults will be below 108. So now we're not comparing each individual IQ score. We're comparing the average IQ score to the entire population. And so that's why central limit theorem applies here, right? So this sample mean, right? Sample mean of 108 is basically the keyword. We know that we have to apply central limit theorem applies here. So this is a major difference between the normal distribution and also the central limit theorem. And here we can actually narrow down to a specific group and try to compare that specific group to the entire population. So instead of just comparing one individual to the entire population. So that means this one has better range, right? In terms of comparing things. Okay. So now the way how we solve this is very similar, right? So you just basically draw the bell curve, visualize this, the mean is 100, right? And then our targeted average IQ score we're talking about is 108. So this average IQ score, X bar, right, is 108. Now we want to find out below 108. That means we want to find out area to the left of 108. Okay. So now first thing is using the z-score formula. So now z-score formula varies a little bit. So X is 108. Population mean is 100. Standard deviation is 12. And the sample size is 20, right? They are all relevant. So now the z-score is equal to sample mean, right? This is sample mean minus population mean dividing by population standard deviation over square root sample size. So it's slightly different. And now the sample mean is 108. The population mean is 100. Okay. And standard deviation is 12 over square root 20. Now I'm going to show you how to do this in Excel or the calculator. They have the same input. Let's go back to Excel. A lot of students make mistake in the statistical analysis class. So I just want to make sure you got it right. So 108 minus 100. Okay, put in the parentheses. That's for numerator. And for denominator, you're also going to put into the parentheses. So that should be standard deviation is 12, right, over square root. So SQRT of 20. And this is the proper input in terms of using the formula to find out the z-score. So I'm going to show you one more time. Okay, and then if we enter, you get a result. And remember, we just run it to 2 decimal place, format cell, 2 decimal. Okay. So this turned out to be 2.98. So the corresponding z-score here will be 2.98. Go back here, 2.98. So we converting the average IQ score of 108 to the z-score of 2.98. Now you draw another, standard normal curve, right? So now no more IQ score, just z-score. So z-score equal 0 here. Now this z-score is 2.98. We're going to look up that in the table B2. Again, we're looking for the area to the left. So we go to the table A2, 2.98. Second page, it's really large, right? 2.9 and 8. So let's show that a little bit. 2.9, 8, yeah. So the 2.9 and then 0.08 will have intercept, and the intercept turned out to be 0.9986, right? So that's what we're looking for, 2.98. So the probability, corresponding probability is 0.9986. So that's the answer we're looking for, right? So this is 0.9986. If you want to put in the standard notation, will be sample mean less than 108. It's the same thing as saying z-score less than 2.98. So from table A2, we get a probability which is 0.9986. Okay. All right, so this is how you find out the probability applying the central limit theorem. All right. Do you have any question on the central limit theorem? And the other two cases, let's say average IQ score between 100 and then let's say 120, you can also follow the same procedure, right? Like the regular normal distribution using the bigger z-score, find the bigger z-score and find the probability for bigger z-score minus probability for smaller z-score, right? Then the difference will be the area in between. So 3 cases: below, between, and above, right? For all this normal distribution central limit theorem, always 3 cases: below, second one is between, third case is above. Okay. Below, you find a z-score, look it up, and that z-score translated to probability, right? In between, you're going to find a bigger z-score using bigger probability minus smaller probability. Okay. And then above, we're just using 1 minus probability. You look up from table A2, right? So 3 different scenarios. And now let's, I'm going to talk about a little bit on I'm going to give you an Excel project today. So I'm going to show you how to find the probability using Excel, right? Okay, let me just share the screen with you. Let me see if I post a review sheet, practice sheet yet. Okay, Excel practice. Square. Okay. Let me see if I do that. Chi-square. Nope, I haven't posted yet. So let me just post it really quickly. You can think about this. Or if you have any question from the homework, let me know from chapter 6. And after chapter 6, I'm going to talk about chapter chapter 10 first, meaning correlation regression. And after that, we come back to chapter 7 and 8. So the order will be vary a little bit, right? 10 first, regression and regression analysis. And then after that, we come back to 7 and 8.
So for next class, we read and do chapter 10, right?
Yes, we do. Yes, we are going to do chapter 10. Yeah. So you can start on chapter 10 lecture, videos this week, and you come back next week and we can talk about that. Talk about chapter. So let me just find out the practice sheet and upload it really quickly so we can take a look at how we handle the probability issues in chapter 6 in Excel.
Are we supposed to be working on something right now?
Yeah, give me 1 second, right? I try to find out the practice sheet we can use to, I guess, let me see if this is the right one. Yeah, just give me 1 second and we can talk about how to find the probability in Excel. You know what? It's okay. We don't need to wait. We can just, I can just give you examples and then we can talk about it. So yeah, this is the one we're talking about. Yep. Okay, so now let's look at this. Okay. So it's called, if you go to the Blackboard, open this file, under the Excel practice, click on this Excel practice, click on Excel practice and go down there. You're going to see Excel project number 4, right? Practice. Yes, open this file, Excel project number 4 practice, and then you will be able to see this file. Okay. And let's talk about this, right? Okay, So you open, everybody open this. So now this question is basically telling us to do this. Find the percentage of data in the standard normal curve. And you want to find out the probability percentage, probability to the left of z-score equal to negative 0.65. Okay. So here, so to the left, right? So it's already the standard, z-score is already given. So we're using normal, standard normal distribution. So lambda_s.dist. Okay. So this is the formula you are using, standard normal distribution with a z-score of negative 0.65. Okay, and you do accumulate everything to the left. So putting argument true, meaning you are accumulating everything to the left. And you hit enter. And that's give you the result. Try that. And the answer should be this, right? So if you want to run into 4 decimal, that's okay. You can do that. Just like what the table gives us. That's totally fine. 4 decimal. Okay. And second one to the right.
Pressing on that for some reason, mine's coming up saying that there's no answer.
There's no answer. One more time. Did you try this? Norm.s.dis.
Oh, I don't think I added the S.
Yes, standard normal distribution. That's very important because it's standard normal curve. Okay.
What is it true for?
True meaning we are accumulating everything to the left. If you put in false, it only gives us the probability when z-score equal to negative 0.65, not including everything to the left.
Oh, okay, thank you.
Okay, so that's true, indicating we are accumulating all the area to the left. Yeah, that's what it means. Okay, so that's how we do that. Okay, get true. And then second one is to the right. And we know that in order to find the area to the right, we're going to use 1, total area 1, under the bell curve minus area to the left. Right, so lambda_s.dist. Standard normal distribution. That's the meaning of this formula here. And putting z-score 0.95. And argument is true, right? Always. If you look at it, cumulative probability distribution, meaning accumulate everything to the left. And if you do false, meaning they only give you probability at z-score equal to 0.95. So it's totally different. So the argument is always true. Okay. And this is to the right, right? Okay. 1 minus area to the left. We get area to the right. So we get that. And now in between, right here, it's just between. So in between, always use the bigger z-score first. Okay, so you do lambda_s.dist. Okay, and put in a bigger z-score, 1.78. And put in true, right? Argument. Now take care of the first part. Second part is same formula. Normal probability, standard normal probability distribution. Lambda_s.dist. And we put in 0.73. Okay. And also true. Okay. Then Excel will automatically give you the answer, meaning we using the bigger z-score find out the probability minus probability corresponding with the smaller z-score, and that's the probability in between. Okay, then we get that 0.1952. And the fourth one is similar, but one of these z-score is negative. Okay. Still positive number is always bigger than negative number. So lambda_s.dist, open parentheses, and putting 1.95 first. Okay. True, right? Minus normal probability distribution. Put in smaller z-score, negative 1.75. Still argument true. And enter. Let's give us the answer. Okay. All right, and then yeah, put it in, right? We got it. So that's the solution. Now question 2. Suppose standard ideal score are known to be normal distribution with mean average 105, standard deviation 18, find the percent of individuals with IQ score above 124, above 92, below 85, between that. So now this one is not a standard normal distribution, it's just regular normal distribution. So you do norm.dist. Okay, so just normal distribution. And for normal distribution, we need to know 3 things, right? The IQ score. But since it's above, meaning we got to do 1 minus, right? Okay, 1 minus norm.dist. I'm putting IQ score 124. Mean is 105, standard deviation 18. And then the last argument is we accumulate everything to the left, true. So that's the proper input. I'll give you 1 minute to look at it. Okay. Okay, so now you hit enter, you get a result. All right, so one more time, let me just run it for decimal place. Okay, so we have that. Second one is above 92. So you're gonna do 1 minus, total area under the bell curve is 1 minus area to the left. You get area to the right. So norm.dist, and put in the x value is 92 here, IQ score is 92, average is 108, standard deviation is 18. We are accumulating everything to the left, true. And let's give you the right answer in 4 decimal places.
Where did you get 108? Did you mean to use 105?
Oh yeah, it's 105. You're right. Totally. Yeah, good catch. And the mean is 105, right? Not 108. Standard deviation is 18. Okay. Very good. So you hit enter, you get a result. So now the third case is below 85. So we could go directly normal probability distribution. X is 85 and mean is 105. Standard deviation is 18. True. Right. And once you do that, you should get the right answer right away. 0.1333. And the last one, part D, is between, right? In between. So we gotta use the bigger IQ score first, which is 119. Bigger IQ score gives us a bigger probability, right? Because bigger Z score gives us bigger probability. And 105 is the mean. Standard deviation is 18. True, right? Accumulate everything to the left. And minus norm.dist. The smaller IQ score 74. And 105, comma 18, comma true. Okay. I'll give you 1 minute to complete this. And he enter, right? After that, that should do it. Okay, get the answer. Now, any question on the previous two? It's fairly straightforward, right? Okay, now watch this. Question 3. So suppose that the height of FIT male students have normal distribution with an average height of 65 inches and standard deviation of 8 inches. Find the height of male students among top 10%, right? All the,
Professor,
yes, yeah.
would you be able to just click on D15 or D13 real quick? I think my answer came out a little bit wrong, so I just want to check my formula.
Yeah, D15 or D13, sure. Yeah, sure. Go ahead.
Thank you.
No problem.
All right, I'm good. Thank you.
Got it? Very good. Perfect. Okay, so we have that. Now think about the third cases. I'm going to show you how to do it by hand really quickly. And then after that, I'm going to show you how to use Excel because this one is interesting. Okay. All right. Now one more time, we have right this particular scenario that the height of all male students at FIT. So this is hypothetical. This is not real, right? I just made it up. It may not be reflect the reality, but just give you an idea, how to separate those different groups. And then the college admission board, right? They use the same kind of, standard for a lot of like SAT scores, ACT scores. They use those to distinguish the students they will accept from the students they will reject, right? So very similar, logic behind it. So it's very interesting thing to look at. All right. So if you want to do it by hand, okay. All right, I'm gonna do maybe a couple of them, just do 2 of them so you get idea. So now you want to see top 10%, right? Top 10% should be located here, right? So you are separating top 10% from the bottom 90%. Okay, so 2 groups. So separating them. And basically here they are giving us the probability, right? The area to the left, also area to the right.
Oh,
So-
we only see the Excel sheet.
Okay, I see. I probably forget to share. Thanks for letting me know. Here we go. You can see it now, right?
Yes.
Okay, very good. So draw the bell curve first. So now the key thing here to separate in 2 groups. They want top 10%. And that means the other counterpart will be about 90%. And 10%, top 10% is on the right tail. So everything else goes to the left. So now the good thing is we can use this area to the left, which is 0.9000. Okay, we can use that to find in the corresponding z-score here, right? Because they want us to find out the height of male students, separating the cutoff height, separating the bottom 90% from the top 10%. Then 0.99000, we use that to find out corresponding z-score. So now go to table A2, right? The second page, and let's see, we have exam match. And most of the time we won't have exam match. We can only find out the best possible match, right? In this case, this number is closest to 0.9000 because it's 0.8997. It's a little bit closer compared to 0.9015. And that is why we're using the closest value. Most of the time, you won't be able to find out exact match. Again, the table has limitations. But if you are using Excel or software, no limitation. We'll be able to locate any probability we want, right? With accurate answers, accurate z-score. So now the best thing we can do from the table is 1.28. That means the cutoff IQ score, the cutoff Z-score here separating the bottom 90% from top 10% is 1.28. Look at that. Now once we have Z-score, now we're using Z-score formula, x minus mu over sigma, right? X is the only thing we don't know. Now we know Z-score is 1.28. We know the population mean is mu is 65 inches, and the standard deviation is 8 inches. Now, if you plug into the Z-score formula, we'll be able to find out the cutoff height, separating the top 10% from bottom 90%. All right, so now Z-score is 1.28. Okay, x minus 65 over 8. Okay, so we're going to turn into proportion, right? Just like how you handle that in the algebra course. And we cross multiply x minus 65, we go to the left, right? 1.28 times 8, go to the right. So x minus 65 should be 1.28 times 8. And this turned out to be 110.24. Okay, then you add in 65. Let's see what the result is, right? So x equal to 75.24 inches. Meaning the cutoff height separating the top 10% from the bottom 90% is this, 75.24 inches. Okay. And this is one of the case. Now I want you, let's look at part D, right? Bottom 15%. Okay. So you are separating bottom 50% from the top 85%. Okay, that's what it look like. And now again, draw the bell curve. So this bottom is 15%. So everything to the right will be 85%. And again, we're using the cutoff Z-score here, right, to separate those two groups. And since we know area to the left is 15%, which is 0.1500, now we can find out the corresponding Z-score from table A2. So now let's go back to table A2. Look for 0.1500, should be on the first page. And if you go down a little bit, you should be able to find out 0.1500. No exact match again, right? No exact match. The closest match will be this one, 1492. That's closest one we can find, right? And we're going to use that. So the corresponding Z-score here will be negative 1.04. Okay. So Z-score, we identify that, negative 1.04. That's what we use to separate the bottom 15% from the top 80%, the top 85%, 1.04. Now, one more time, once we know the Z-score, right, based on this area to the left. So now using the Z-score formula, we're looking for X. That's what we're looking for. We don't know that. We know Z-score, negative 1.04. We know that the mean average, population mean 65, standard deviation is 8, right? That's all given in the question. Yeah, it is. Okay. Now, throw into the formula, look for the X value. So we have a Z-score equal to X minus mu over sigma. Z-score is negative 1.04. X minus 865 over 8. Then we turn into a fraction, proportion, just like the previous one. Then we cross multiplying X minus 65 equal negative 1.04 times 8. And X minus 65 equal negative 8.32. Okay. Now, if you're adding 65 from both sides of the equation, so you get a solution. Okay, then let's see. So x equal to 65 minus 8.32. And this is 56.68 inches. Okay, that's what separates bottom 15%, right, from the top 85%. Now let's go back to the Excel. This is how you do it by hand, but in Excel it's so much quicker, right? So top 10%, but you still need to, the key thing is to understand the rationale behind it. Otherwise, you wouldn't be able to use the formula easily. So it's called non-dot, it's non-dot IMB, right? Meaning inverse of normal distribution. Basically, this is inverse process. And in terms of, for the probability, you put an area to the left, right? Since it's top 90%, that means area to the left is 90%. You cannot use area to the right, right? Otherwise, your answer will be totally off. Now, once you have that nailed down, that's the most important thing. Now, put in the mean, 65, standard deviation 8. Okay. And once you have all of these three elements ready, then key enter. You see that 75.25. You run down 2 decimal place, 75.25, right? Go back to the calculation we have, 75.25, right? Because again, Excel is more accurate, right? But they are very close. Okay. Here, because of rounding, so in Excel, there's no rounding. Excel use the exact answer to get a z-score. Okay. That's why the answer is so close, but not exactly the same. Okay. And then the last one, we also did that one, right? So you do the same thing, inverse of the normal distribution. Area to the left is 15%. Okay. Average mean is 65. Standard deviation is 8. Okay. All right. Always area to the left, right? Excel, table, or any other software, by default, when the programmer coded the program, they always use the default area to the left. Okay, that's always the case. So that's why Excel follows the same thing as the table. And most of the software follow the same logic. So area to the left, put it in 15%, put in the mean, put in the standard deviation, good to go, right? You get that. So if you run it to two decimal, this one actually should be very close, 56.71. If you go back to the calculation we have, yeah, 56.68, right? Yep. So it's very 71. So it's off a little bit. Again, it's because Excel is a lot more accurate. Okay, but yeah, that's tolerable, error here because of rounding, because of limitation of the table. Yeah. Okay, so now I want you to try the other two, right? Bottom 10%, top 15%. I give you a couple minutes, try that, and then I will show you the solution in a bit. Okay. All right, let's go over the solution, and then you can get started on the Excel project number 4. Okay. So now bottom 10%. Again, bottom 10%. So we are getting the average to left directly. So the norm dot inverse of the normal distribution. So average to left is 10%. And then the mean is 65. And standard deviation is 8. Okay. And once you input properly, you should get a result right away. So this turned out to be 2 decimal place. You just format to 2 decimal place. And also the last one, top 15%, that means on the bottom, on the left is 85%. So non dot BIS dot inverse. Inverse of normal distribution. And bottom 85%, putting 85%. Mean is 65, standard deviation is 8. Okay. And that's how you do it. And once you have the right input, you get a result right away. Okay. And any question on this? All right. So you still have 20 minutes. I already posted Excel project number 4. It's due by next Monday after class. So it's very similar to what we just did, right? If you understand what we're doing so far, then you should be able to finish the Excel project number 4 with no problem. And under Excel project submission, open the Excel project number 4. Let's take a look at it together. Okay, very similar, right? You're given the standard normal curve first question, just like what we did. Find out the area to the left, to the right, between. Some second one, the number is different, obviously, right? But the logic is all the formulas we are using the exact same formula. Okay. And the third one is top bottom 20%, top bottom 12%.
Professor?
Mm-hmm. Yeah.
For some reason, it's like frozen on where it's like listing all the Excel projects. Like, I don't see your project. Oh, there we go. No, I see it.
Okay. Okay. Very good. Sometimes it's internet is very, it freezes, but you'll be able to get back that later. Yeah. Okay. And yeah, you should have no problem finish this, right? We just went over all the detailed calculations, and you can get started on it. Okay. And again, I'm gonna put you in a breakout room, and you can talk to me if you have any individual questions. Okay. And you can get started on an Excel project due by Monday, next Monday. Okay. Hey, Neil.
Hello.
Hey.
Hi. I was doing my Excel project. Can I share my screen?
Sure, go ahead. You can share the screen.
So this is my Excel project that I just completed. And so one thing is on Google Sheets, it won't let me write true right here. Like you can see, it will underline
That's okay. So they probably take it for by default, That's okay.
Okay, I just don't want points off for that.
That's fine, totally.
Because down here, it would let me write true though.
Yeah, for some
And then
reason.
also while I transferred the sheets to my Google Drive, number or letter A is after B, C, and D, just by the way, while you're grading mine.
No problem.
But does it look pretty good?
I think so. Yeah, you did a good job. I think.
Okay.
It looks good to me.
And down here, it won't let me put the dot between them. Is that okay?
Okay, yeah.
Okay, I wasn't sure if it was
That's
like a different if it was like a different thing. Okay, so mine looks good.
Yeah, it looks good. Yeah.
Okay, thank you so much.
No problem. All right. Hey, Asma.
Hi, yeah. So I had a quick question. I know you said that you extended the quizzes, but when I checked, I have one quiz past due. I was trying to do it today, but it didn't let me do it because it was past due.
No worry, I can extend it for you. Give just one second. Right? Let me go to your account.
Yeah, 'cause you
You
said
can
you
tell
were
me.
extending the quizzes till the end of the semester.
Okay. Yeah, I extended most of the. Yeah, the. Okay. Which quiz you talking about? Maybe 3, 4, 5.
Yeah.
Okay, I can do that. So I extended till the end of semester. Okay, it's good. You should be able to have access to those quizzes now, right?
Okay, yeah, thank you. And also thank you for the midterm.
Okay, make up. Yeah. I know some of you guys may want it, so
Yeah.
it's
Yeah,
good for you. I
I
think for
did it
you,
for
it's a big
second
difference,
too.
right? It was very good.
Yeah.
You did a good job on the second trial.
Yeah, the first one was terrible.
Yeah. But the second one is a lot better. Yeah,
Yeah.
it's
Thank you
great.
very much.
No problem.
Yeah.
Okay.